As we start chapter 13, section 13.1, we're going to learn about finding where a function is increasing and decreasing using our calculus. And so this little box talks about the test for increasing and decreasing. Suppose a function f has a derivative at each point in the open interval, and then if the derivative is positive in that interval, then the original function is increasing. If the derivative is negative, less than 0, then the original function is decreasing. If the derivative equals 0, then f is constant on the interval. Now, in order to do this, the first thing we have to understand is finding the critical numbers. And the critical numbers are those numbers that are in the domain of f for which either f prime of that number is equal to 0 or f prime of that number does not exist. And so a critical point is the x coordinate of that critical number c. So we'll find the critical numbers, so you needed to know that. Now, what we're going to do, without just reading these steps, let's kind of go through this problem here as an example. If you're given f of x is equal to x cubed plus 3x squared minus 9x plus 4. That's what we're given. That's our f of x. So first find the derivative. Find f prime of x. So 3x squared plus 6x minus 9. At this point, after chapter 12, we should know how to do those fairly simply. Then you take that derivative and set it equal to 0. That's how we're going to find the critical number. So take the derivative, set it equal to 0. In this one, I divided everything by 3. That's just algebra. And then I got this. I'm going to factor this, and I get x plus 3 and x minus 1, which gives me x equals negative 3, x equals 1. Now, the way I like to do it is I draw a line, and then I put however many critical numbers, I put that many hash marks. So I did that. And I'm going to put them in order. So this one would be x is negative 3. This one is x equals 1. The next thing I would do is on this line, I would define the intervals. This interval is from 1 to infinity. This interval is from negative 3 to positive 1. And this one is from negative infinity up to negative 3. So we've got that. Then you pick some test points within those intervals. So it can be any number from negative infinity up to negative 3. And it doesn't matter what you choose as long as it's in there. But make it easiest on yourself. You don't want to pick negative 59.7. It's in the interval, but you don't want to have to fool with that. So you want to pick something as easy as can be. So I picked negative 4. Here I picked 0. And here I picked 2. And I always write f prime of that to remind myself I'm going to plug into the derivative. So if I plug negative 4 into the derivative here, I'm just trying to find out, do I get a positive number? Do I get a negative number? And so for this one, I got positive. Then if I plug in 0, I'm left with a negative 3, so I have a negative number. For 2, I'm back at a positive number, so I write those down. So now that we have our plus, minus, plus, you can actually, I like to take a little highlighter and I say, okay, this is a positive slope. So he's going up at x equals negative 3. It's right there. And then for this one, it's negative, so it's coming down. And then again, it's going up. So our original function should be doing this. If we put this in our calculator, we would see something that did that. And so it is increasing from negative infinity to negative 3 and from 1 to infinity. It's decreasing from negative 3 to 1. So that's what we're going to be doing on our problems, and some of them will not be as straightforward as taking the derivative of a polynomial, but we should know what we're doing. So let's go look at our problem set. All right, here are our problems that you will you will encounter in homework, similar to this. So number 1 says find the open intervals where this is increasing or decreasing. So you're really not having to do any work, you're just analyzing. So I went ahead and color coded. Decreasing was yellow and green was increasing. And where does it change? At the vertex here. So it changes at x equals -2. And so we always want to remember this is negative infinity out here and this is positive infinity. So this says, where is it increasing? Well, it's increasing from -2 all the way to infinity. We're talking about the x, but it goes on to infinity. And where is it decreasing? From negative infinity up to -2. So that's number 1. Number 2, find the open intervals where this is increasing and decreasing. So on number 2, it's the same thing. Where is it increasing and decreasing? Well, it's increasing up to here, then it's decreasing, and then it's increasing again. So it changes at -1, x is -1, and at +1. So how should we fill in the answer? Okay, I added those in. So where does it change? -1 and 1. So where is it increasing? The two yellow ones, from negative infinity up to -1, and then it starts again at 1 and goes to positive infinity. Be sure you put this comma in between those two intervals. And where is it decreasing? From -1 to 1. So that should be number 2. Number 3, we're still analyzing. We have a 4th degree, and we've got decreasing here, increasing and increasing. Where do they change? They change at -4 and at x is 0 and then +4. So it's increasing on -4 to 0 and then from 4 to infinity. Got that there. It's decreasing right here, so negative infinity to -4, and then it's decreasing here, which is 0 to 4. So there we've got those. And those first 3, like I said, are just analyzing. We're not actually doing calculus there. We're just analyzing those. So let's go look at no. All right, so I rewrote that a little bit larger there. So there's our function. It's a quadratic. So when we take the derivative of that, the derivative of this piece is 0. The derivative of, and I went ahead and put it in order because I would have preferred the x squared term to be at the front, so I did this piece first. So the derivative of this is -1.8x. Derivative of this is 2.8. Take that, set it equal to 0, subtract this piece over here, divide by this piece, and if you look here, 2 is going to go into each of those if you think about it. And so when you reduce it, you come up with 14/9. Or if you divide this in, you can do it. I can show you that on the calculator. Let me grab the calculator. So if we just take this and did it on the calculator, -2.8 divided by -1.8, and we hit enter, we're going to get a decimal number. Let's change that to fraction by hitting math and enter on fraction, and enter one more time, and we got our 14/9. So that is going to be our answer for our critical number. So let me move that out of the way. So that's our critical number, and that's the first part of the question right here. And then we can make our little chart. There's our critical number, and on this side it's negative infinity to 14/9, and on this side it's 14/9 to positive infinity. We'll do test points, and this is higher than 0 here, so we could do f prime of 0 for a test, and this is 3 is definitely a whole number that's bigger than that, so f prime of 3. We get a positive value this side, a negative value this side. So here's our increase, here's our decrease, and we plug those in there. So that's number 4. Let's go to number 5. So here we are at number 5. Here's our cubic function. We take the derivative of that and get 36x squared minus 90x minus 216. I set that equal to 0. And one of the ways, so this doesn't look like it's easy to factor right there, but we could do a couple of things. We could divide everything by 6. That'll give us 6x squared minus 15x minus 36, I believe. But if not, one of the ways when people get stuck on factoring, so one of the things you can do, and I just want to show you that in case you get stuck. So if you come over here and you go to y equals, and I'm going to clear that all out, and I'm going to put in 36x squared minus 90x minus 216. And so you note that I've got y2 to be 0. So when I do a zoom 6, and I can see that this graph is doing this, what I'm interested in is finding out the solution to that f prime, that quadratic. So I need this number and this number. And I can do that by doing second trace, second calc, intersect number 5, and hit enter 3 times. 1, 2, 3. Pops to this one. That's 1.5. Then I can do it again, second calc, 5, but before I hit enter, I want to move till I can come back around. You see those numbers on the y are getting smaller. I'm almost, whoops. I think you can't see it. Let me just go ahead and hit enter 3 times because I'm on that side. And there's my x equals 4. So that's a quick way to get those if you got stuck and couldn't see the factoring. Hopefully you know how to do that. But if not, that's what you can do. So x equals negative 1.5, x equals 4. And I put those in my line. I defined my intervals. I did my test points. And I found positive, negative, positive. And so you could see that this is going here, and then you're coming down here, and then you're going back up, which would give you a cubic thing. So your original is going to look like that. And I did not fill into the answers up here, but the critical numbers are negative 1.5 and 4. That's going here. It's increasing from negative infinity, and then I think they want fractions. It says integers or fractions, so they don't want the decimals. I changed negative 1.5 to 3 halves. So negative infinity to negative 3 halves, and then put a comma. I did not have the comma here, so you would need that there. And then 4 to infinity, and then it's decreasing from negative 3 halves to 4. And so that should get you number 5. Let's go look at number 6. All right, number 6 is a quotient. So remember our roadmap, the bottom times the derivative of the top minus the top times derivative of the bottom, all over the bottom squared. And I came down here and I've got that. Now when you distribute this minus, you get this. All right, so here we have x minus x. That means x has gone away, and 2 minus 9 is a negative 7. So this is our f prime right here. And when we go to set that equal to 0, so what we can see is if we multiply this to the other side, we've got 0. Well, the numerator is never going to be 0. So there is no solution to this thing. So remember that a critical number is where the derivative is equal to 0. Well, we don't have that. Or where it doesn't exist. And so it's undefined at negative 2. But negative 2 is not in the domain of the original. Negative 2 is a problem there. So we don't have any critical numbers, and that's the first thing here. There are no critical numbers, even though we have that stuff. But using where it's undefined, we can still check where it's increasing and decreasing. So if x is -2, then we have our two intervals, and we end up with negative on both of them. Did f prime of -3 and f prime of 0, and we got that. And so the function is never increasing. It is decreasing on both of these intervals, and we probably need to have our comma there. So that one's a little different. Just pay attention to this information here and know that there is no critical number, but we can use the undefined number to figure out where the thing is increasing or decreasing. Let's go look at number 7. All right, for number 7, we have x plus 7 to the 2/3. And we have to use the chain rule for that. So when we come over here, f prime of x equals, we're going to put the 2/3 to the front. There's that. Take 1 away from 2/3, so that means we're left with -1/3 times the derivative of the inside, which is just 1. So this right here is our derivative. When we go over here and set it equal to 0, that's x. We can divide by the 2/3, that's gone. We can put this on the bottom to get rid of that negative exponent, and we have 1 over x plus 7 to the 1/3 equals 0. Well, our numerator's never going to equal 0, so it's undefined at x equals -7. So we do have that. We don't have a critical number from just solving the derivative equal to 0. But we do have where it's undefined, and it's undefined at x equals -7. Now, we have to see whether -7 exists in the original. So if you take that, if you did it on your calculator, -7 plus 7 is 0, and you can raise 0 to the 2/3 power, and you get 0. 0 is okay to get. So -7 is a critical number because it's undefined there, and it does exist in the original function. So that's our critical number right there. Then we do our little test here, and we have x equals -7. There's our intervals. You do your test points, and you end up with a negative here and a positive here. So decreasing in this interval and increasing in this one. So we did have a chain rule. That's a little different, but it wasn't too bad. So let's go look at number 8. Number 8's an application problem, but we're still doing the same kind of thing. So a manufacturer sells video games with the following cost and revenue functions, where x is the number of games sold. Determine the intervals on which the profit is increasing. All right, so we've got, here's our C of x, here's our revenue, R of x. Well, profit is equal to R minus C. So you literally have to take the revenue and subtract the profit. And so that's some algebra, just, distributing that minus, getting like terms together, and you end up with this. Then you're going to take the derivative of it. And so you're going to multiply that. You end up with 0.51 x squared minus 3 times that, 0.001 x. Let's see. Now, I'm not doing that right there. That's crazy. I was looking at it and not even looking at what I was saying. So I am so sorry. We're combining like terms here, and we have 0.51 x squared, and then we combine the x cubes, and we have here. Now we're taking the derivative. So when we do that, 2 times that, 1.02x, minus 3 times that, 0.0003 x squared. That's our derivative. And set that equal to 0. Now what you can do on this one is factor out an x, which leaves you this factor and this one. And then if you take this and set it equal to 0, subtract that to the other side, divide by the negative 0.003, And then you end up, if you do this on the calculator, you get a big number. You get 3,400. That is one of your critical numbers, and x equals 0 is the other one. And because this is an application, we can't go to negative infinity, and so we're really constrained on that. So when we do this, we have x is 0, x is 3,400, and your two intervals are 0 to 3,400, and you could say 3,400 to infinity, but we don't have anything over here because we can't be in the negative. When we do our test points, I did f prime of 1, f prime of 3,401, and when you test those, you get positive and negative. And so all it's saying is, where is the profit increasing? And so that's here, and so your answer is 0 to 3,400. So it had some crazy numbers in there, but you're doing the same thing that we've been doing. All right, let's do our last one. It gives us a function approximating the blood alcohol concentration in a person's bloodstream X hours after drinking 8 ounces of hard liquor. The function only applies to the interval 0 to 6. So we already know that we're limited there. On what time intervals is it increasing? And that has to make sense to you, because ultimately the alcohol gets absorbed into the system, and there comes a point where it's not increasing, and it will be going away. So let's go down here, a of x, and that kind of got cut off on my page, but here's what it is. A of x is your basic function. We're going to take the derivative of that, 0.006x squared minus 0.06x plus 0.14. And again, I'm just telling you here, I would put this in y1 and this in y2 to be 0, and get your two x-intercepts, which are 3.709 and 6.29. They want everything, let's see, I think they said hundredths. But we couldn't use 6.29 because we were constrained to 0 to 6. So we're going to cut that one to 6, and we're going to make this one 3.709. In our answer, we'll make it 3.71 for the hundredths. So here is, we couldn't use this number when we found the critical numbers. It didn't exist in our domain. So we're just using this guy. And we have x is 3.709, 0 to that to 6. Test 3, test 4, you get a positive and a negative. That's going to allow you to do, where is it increasing? Well, it's increasing from 0 to 3.71, and that's that high point. And then it's going to start decreasing from 3.71 to 6. So same idea that you've been doing in all of those. It was just an application problem. You had some constraints on your domain, and you were given those in the beginning of the question. So I think that's going to get you done on increasing and decreasing. Just remember, you're finding your critical numbers, or the places where your derivative does not exist, if that number is in the domain of the original function. Then you're doing all of the tests that we've done, so I think you are good.